recording and the chat window. And then we're good to go. Okay, welcome everyone one last time. So this is our final lecture in the advanced course in programming and the entire course in programming. So it's week number 12. And once again, we continue on where we finished last week. So last week we basically moved on from object-oriented programming and talked a little bit about some functional features of Python, things like list comprehension and dictionary comprehensions, and a little bit about filtering items in comprehensions we found quite useful. And then as a whole other topic, we talked a little bit about recursion. And today we're going to continue about some functional features of Python, and then we're going to talk about something else at the end of this session. But let's start straight away. So we've been sorting some things already. We know how to sort out a list of numbers, and we know how to sort out a list of strings, for example, and then we talked briefly about sorting our own objects, which is fine if we only want to sort our own objects by a specific criteria. But if you have a bunch of student objects and then you sometimes want to sort them out by the student number and sometimes by the number of credits and sometimes by them starting year or something, which all could be quite useful if you're running a system for student registry, then that's sort of problematic. And even sort of simple things can be difficult. Let's say that we have a list of tuples, something like this. For example, so what happens if I sort this list? Sort of depends on if I know how to spell tuples like that. Yeah, made it. So what happens? No, you don't write the entire list, but basically, what is Python doing? Yeah. Couple of good answers. So first one is the correct one in this case. I think sort by order of the first element in the tuple. So let's try it out. And yeah, we can see that it sorts it out by using the first item in its tuple. So what can we do if we want to sort it based on something else? Because if we have a list of tuples, especially if tuples contain something other than integers only, or if there are more than one integer in its tuple, or anything, if we want to sort it out or sort it based on a different criteria than the first item, we need to do something else. And what we can do is define a function for, like a helper function for sorting, and the idea of function is that it returns a value for each element, and then that value is used in sorting. So let's start by writing a function. And then it doesn't really matter what we call the function, but we will see eventually. Then we just return. And let's say that we want to sort a list of tuples based on the second element in each tuple. So what we do is we return the second element, so the element at index 1, that is. And now what we need to do is tell the sorting function that, or the sort method in this case, that we want to use our own value function for this one. So we basically define that the key for this one is the value function in there. Let's see what happens when we sort it out. And now if you take a look at the outcome, you can see that the list is sorted based on the second item of each tuple. So it's 1, 2, 2, 4, and 7 in that order. We could do something else. do something like this. So what is the basis on sorting the list now? Yeah, so now we take the sum of each tuple. So let's say if we sort it out, it's actually quite similar to, no, it isn't exactly similar to the previous one. So it's 1, 4, 3, 2, 5, 1, 2, 7, 7, 2. See, so it's 5 and 5 and 6 and 9 and 9, basically. So so what this means is that we can define any value function we want and use that as a basis for sorting this out. And let's output the tuple here just to see what happens. And if we output it, you can see that it actually all the tuples in a list go through this function. So all these tuples are passed as arguments to this value function in here. So basically, all the elements, they seem to be in this order. So what Python does is that it actually passes all those items into that function so that it knows what is the value of each of those items, and then it uses that value to sort the list into natural order. A good question, how does it decide which one should come first for the sum part 1.4 or 3.2? I think that's, well, it has a certain algorithm it uses to sort it out. It uses an algorithm called merge sort, actually. So it's sort of, there isn't really like any particular rule for that one. It just picks one of those. In merge sort, it's probably the one, or not always, but in this case, because the first one is already in the first item in a list, then it stays in there. I think that if we change the order of these, we can take a look, then it probably means that that one stays as the first item. So in most of the sorting algorithms, I think the essential thing for the effectiveness of sorting algorithms is that you try to do as little as possible. But there are various different sorting algorithms, and if you're going to take the algorithm course later, which I hope that at least some of you will take, there's a lot of discussion about different sorting algorithms over there. There are a lot of different ways on how you can sort things out algorithmically. In programming languages, we mostly use the built-in algorithms, like in Python, because those are quite effective. But there are a lot of ways to actually implement those algorithms. Some of we and so on. But anyway, in this case, the value of these two items is the same. We have decided that the value used in sorting is the sum of these items, so it doesn't really matter what is the order in this case, because we haven't defined that if they have the same items, what is the value then? Okay, let's try something different. I think it's also a good idea to sort of name this function. Value isn't really a good name for this one. Could be something like sum of items instead, I think, which actually tells us that this is the name of the, or actually it tells us what the function does. So it actually returns the sum of items in this case. The key is not a string. The key is basically any type. As it says there, it's any. So the basic idea is that it can return any item that is sort of sortable. So in this case, what happens here is, and that's a great question. That's actually what we're going to talk about next is that the value of key in this case is a function. So the sum of items is a function. It's not a string because it's not enclosed in quotas, and it's not supposed to be a string. Actually, string isn't allowed in here. So the idea is that we provide a name of a function, and then Python uses this function to get the value for each of these items. So if we provide something else, okay, let's have a product, for example. we can provide the name of function in there. And important thing to figure out in or realize in this point is that this is actually the name of the function. So we don't provide any parentheses in here. Why not? What would happen if we actually provided parentheses at the end of this name over there? What would it mean? That's a question. Yeah, exactly. So in this case, we are trying to pass the return value of the function product, which actually can't be called like this. There's no say, yeah, it would be an error if we can't call the product like this. And even if we provided a parameter or argument in this case, it wouldn't really matter because that's not what we're trying to do. We're trying to actually pass a function as a reference, which is one of the things we're going to talk, or we are talking about it at now. One of the things we're talking about today is that in Python, we can actually pass a function as a reference, as an argument. So we can try that out. So now the list of tuples is sorted based on the product of each of the items. So it's 1 times 4, 5 times 1, and so on and so on and so on. Okay, let's see something else. So let's say that we're let's say that we're writing a function which is supposed to sort a list of tuples based on the last item of each tuple. So something we did already. And we're returning a sorted version of the list. So it's tuples and then the key again. And now we need the key function. What we can do is we can write the function inside a function. So let's see. Something like this. And then when we sort it, we see that it works. So what happens in here is that now we define a function inside a function. What do you think that means? I mean, you're starting to be somewhat experienced programmers. What do you think is the idea in here? What is like the implication of having a function inside, function defined inside another function definition? Yeah, exactly. Excellent answers once again. So the function is only available inside this function. This last item function cannot be called anywhere outside this function. What is the point of that? Is the fact that if we really only need a function in this scope, it's something like in a case like this, it can be actually sort of probable that we do, because everything the function does in this case is that it returns the final item of the tuple, and getting the final item of a tuple anywhere outside this sorting function is rather easy. We just take the item, reference the item by the index number 1. So we don't really need this function. But the reason we need this function is here is that we, for the sort function, in this case sorted function, we need to provide the key function or the value function, and so we actually need to provide a function for this one. This one needs to be effectively a function, and that's why we can define a function inside another function. There's a question: can we also set key to something else than a function reference? basically we're supposed to use a function reference or something callable, that is. But the thing is that we can also use our own functions. Sorry, this is our own function, but we can also use built-in functions. Let's see something else. Let's get rid of all of this for a second, and let's have something like names. And let's have Bob in there, and David and John, and give me one more name. Sort of difficult to try to come up with this on these live lectures. I should have like a list of names or something. Yeah, pizza is great. Thank you. Okay, let's say that we want to sort. Okay, let's start by sorting out the list of names. So what happens if I sort it out like this? What will be the outcome? You all know this, but let's just remind ourselves. So how is the list of names sorted if we don't provide anything, yeah, it will be sorted alphabetically. So if we sort it out, it will be Bob, David, John. John was that one twice, something like so over there. Bob, David, Joe, John, Marianne, and Peter. Let's say that we want to sort it out based on the length of those names. So we want to have the sorted, the first name to be the shortest name and the final name to be the longest name. What we can do is provide a key. And now we don't need to define the length function because we have a length function. It's called len. So let's just use that one. So if you think about the len function, what it does, you provide as an argument a sequence, and then the len function returns the number of items in that sequence. So basically the length of that sequence. And we've been using it with strings and with lists and with dictionaries and with whatever items, with whatever sequences. So basically it works for this one as well. So now we have Bob, Joe, John, David, Peter, and Marianne is the final one because that's the longest name. So we can provide any callable function in here. It doesn't need to be implemented ourselves because len is a function that provides a value for its argument, which is basically what most of the functions do. If they have a return value, they provide a value. And if you want to sort based on that value, then you can use it as a value function for your sorting. The thing is that this key argument also works for some other functions. So what will this output? What do you think this will output? Yeah, it basically it does output the longest word. So in this case, it's Marianne. Or if there's a something longer in there, then it returns that one. But the basic idea is that we can provide a key. There's an optional key parameter for max and min functions as well. You take the minimum of the same list, then it's Bob, because Bob is the shortest name, or it's one of the shortest names. Again, the minimum. If there are several items with the same minimum value, then the min function returns one of those. So again, this is quite useful. You all know how to pick the longest or shortest or minimum or maximum of any list by yourselves, but the fact that you can provide a key or have a key parameter for min and max functions also makes it really sort of easier to accomplish. Again, we can write our own function if we want to. Okay, so what does the, let's start with this one. What does the vowels function return in this case? Yeah, exactly. It returns the number of vowels in a word. And what it does is that we use the list comprehension we discussed the last time. So basically what we do is we picked all the characters in a string if the character is in this list of vowels. And what this means is that for any string, we basically get a list of vowels. And then when we get the length of that one, we get the number of vowels in that given string. And if we use it for sorting or minimum or maximum, like in this case, this one gives us the name with least vowels, which is John, or could have been a Bob as well. And if we get the maximum of the same thing, then we get a long name John, which has the most vowels. And if we sort it out similarly, then again we get a list of names sorted based on the number of vowels in each word. Okay, so in real life, you probably don't need to sort by a number of vowels in a word, but this is just to sort of demonstrate that this can be really sort of a powerful mechanics. You can do a lot of things with a really sort of a simple construct based on this one, because you can write your own value function, and it can be something more complicated than just a single return expression. You can do a lot of things. You can do whatever you want inside this function in here. So what we could do, basically, we could do something like, let's say, we could have a huge text file, something like 2 megabytes long, and we could write a value function based on how many times each of these names appear in that text file. And we could sort a list of names based on how many times they appear in some kind of text, for example, which is it's simple to do. You could all do that. It would probably take something like a couple of minutes. And but then again, it's something that would be really difficult to do outside of programming concept. Really difficult to do with anything like, I don't know, whatever tools. Okay, let's take a short look at the slides. If I forgot to tell you anything about this one before we move on. Yeah, we define functions. Yeah. Let's go over there. Now, if you think about something, an expression like this, and especially an expression like, let's get back to having a list of tuples again. One over there, actually. So let's say that we want to sort by the last item, like this, for example. Let's have the last item over there. Last item, and then we have a tuple, and then we just return the second. It exactly could be the second item because it doesn't return the, well, then we can just return the last item like this. So now it works for any tuple. Doesn't really matter if some of these tuples have more than more items. So we sort it out and sort it out. If you think about this, so and what someone asked before in chat, which I think was an excellent question, was that do we always need to write a function for this one? Because this seems sort of like a bit like an overkill. It's like we need to define a function which we're not going to use for anything else. And even if we have a separate function for sorting out and then a function inside that function, we still need to write that function. And we're not going to need a function called last item for anything else because we have this operation for retrieving a final item of any tuple. What we can do is use something called an anonymous function, which we can perform with the lambda expression. And the idea of lambda expression is that the syntax is displayed in here. We have a keyword lambda, then we provide the parameters, then a colon, and then the expression. And this whole thing is a single expression. So we can use it inside another expression or in a statement. And what this means is that if we want to use the final item as a basis for sorting, for example, instead of writing the function or defining the function with the def keyword like we did here, we can use the lambda keyword and just say that for any item, we return the final item like this. So we basically define a function in here. We use the lambda keyword and we define a function which has a single parameter. In this case, it's called item. And then the value the function returns is the item -1. So basically the final item in a tuple in this case. So what it means is that we can call this function anywhere else. Get rid of this one. But as we talked about before, we don't really need to call it anywhere else, because basically we are defining this function just to sort this list of tuples in a particular order. That's basically what we're doing in this case. So there's really no point in defining this function anywhere else. So we can use the lambda to just define the function like this. Or we could, yeah, exactly. Key now holds a reference to a function without a name. Yeah, exactly. So we define the function, we can't call it ourselves because it doesn't have a name. It's an anonymous function based on that one. And because it doesn't have a name, we can't call it ourselves, but it doesn't really matter because we don't want to. What we want to is use that function to retrieve the value of each of these tuples in a list. Change it like this because we don't want to have any of these irregular tuples over there. Something over there, and whatever we want to do in here for each item, we can say something like item 0 times item 1, which was the way to sort it based on the product of each of these items in each of tuple. So it's 1 times 4, 5 times 1, and so on and so on. So basically, we can define any function where the return value can be expressed by a single expression. Like in this case, if the return value is something more complicated, like for example, that we're reading something from file, or what was the example I was talking about earlier, then you need to define it yourself. But if a return value is something simple enough to be expressed as a single expression, then we can use the lambda. A good question, can you assign function references to new variables? Yes, we can. And we can do it for any function. Let's again remove this for a second. We can do something like this. Well, let's start with this one. We can do something like this, for example. So what do you think this one returns? 5, yeah, and why 5? What is the reason it returns 5? Yeah, it's the length of ABCDE, as the name implies, and what we're doing here is that we are assigning the function len into a new name length. The len still works, it doesn't remove that, but you can have more than one reference to a function as well, like we can do to any sort of object in Python. Function isn't object in a strict sense, but basically it's a named thing in Python, meaning that we can have several names referencing it. Something like this can be useful if you're, for example, importing something. Say that we are importing random and we want to use the randint operation a lot. So we can do something like this, and then we can just output the random number between 1 and 100 by using R. R is not really a good variable name for this one, but anyway, inside a certain scope, for example, inside a function or something, this could be useful if you need to do a lot of these random in assignments, for example, for different variables or things like that. So if in Python we can do this. In Python we can also do this. What will the program output? Yeah, you're really quick with all this. Yeah, it returns 9, and it returns 9 because we defined the function with lambda, and the lambda function now has 3 parameters, x, y, and z, and it returns the sum of x plus y plus z, and then we assign the lambda defined function in the variable s. So you can do this in Python, but you're not supposed to do this in Python. The Python style guide explicitly states that you're not supposed to assign the lambda generated functions into variables. So if you want to have a function s like this, what you're supposed to do is just write, like we've been doing before, something like this, and then return x plus y plus z. So this is like the proper way in Python to define a named function. A thing we've been using since the first course, since like the, what was it, week 3 in the first course or something like that. So even though this is possible, you're not supposed to do this. And I think the reason is that this is like the basic way to define a named function. It's also more readable, and it's more easy to find in a longer code as a function definition than the lambda. But lambda is great when you need to define an anonymous function. So again, we could do something like let's sort it out. So what will the program do? Yeah, it sorts by ascending order of the negative values. So basically, if you sort it out, effectively what it does, it sorts it into sort of into decreasing natural order, because it takes the opposite value, like the negative value of each item, and which means that the largest item becomes the first item. So this is basically equivalent to sorting it out and then sorting it and then reversing it. What will the program do? No, we can't do that. Sorry. Forget it. Do this. This isn't really useful sorting, but yeah, it's sets the items in random order. So if I execute it, several times, I get a supposedly a different order each time. There are better ways to shuffling something. There's a random shuffle function, but effectively this does the same exact thing. And why I wanted to see this one is that even though when we provide a value for the key parameter, you need to provide a function that receives exactly one argument, or which has exactly one parameter, like in this case lambda x, but you don't really need to use the x in the actual expression. Which is same for any function. You can do something like this. So this is perfectly valid function in Python, but there's really no point. But you don't need to use the parameter inside the function. And in this case, you don't need to use the parameter inside the lambda defined function either. But you need to provide a single parameter for this one because the key parameter wants to have a function with a single parameter so that it can pass all the items as arguments to that function to know their value, which can then be used to sort the whole list. Is there something more you want to know about this one? I think I've any other examples or anything like that. Yeah, good questions about the number of parameters for lambda. There can be more than one parameter for lambda for numbers, right? There can be not for sorting, but there can be any number of parameters for lambda. So again, I'm assigning a lambda into variable just to show it to you, but let's say we can have something like, as we saw before, something like this, for example. So it's possible to have more than one. More than one parameter for lambda. It can be any number of parameters. And actually, there doesn't need to be any parameters. So something like this is valid as well. There's really no point in this one again, because what happens when we give two parameters to lambda assigned as a key to sort function? So if you provide something like this, it probably throws us an error thing like lambda missing one required positional argument item 2. So in this case, the key parameters should have a function with only one parameter, because that's how the sorting function calls the function for all these items. So in this case, it doesn't work. So the key needs to have exactly one parameter, like this. Hey, let's have a 5-minute break. I'm going to get some more tea. In this case, I'm going to stop the pause the recording. So if you want to, or you're going to have a quick break, whether you want to or not, but if you want to get more coffee or something, just help yourselves. So let's continue in 10:58. Exactly recording. There was a question. Yeah. Okay. Yeah. Sorry about the delay. My voice is a bit down. I'm hoping this drinking too much tea helps. So there's a question, is this possible for if you have a list of numbers and sorted numbers and the key is lambda, and then we just, yeah, definitely if we just want to multiply each item by 2, yeah, we can do anything we want with the lambda. But for not exactly like you're written it. So the key needs to be a variable, not an item from a sequence. So I can't do anything like this in here. It doesn't work. It's a syntax Python doesn't understand. But we can multiply the item by 2 for this one if you want to. But this is basically a parameter definition, like we use in any function definition, like we use with the def keyword when we define the parameters. This is a similar parameter, and then we can use this parameter in this expression, like we use with other functions. Now, the thing in Python is that, like we've seen here, is that we can provide functions as function parameters, which is sort of not function return values, but the functions themselves. So I could write something like this. doesn't work. Just have a parameter. And in this one, we return the result of calling the operation with parameter. So basically, we write a function that has another function as a parameter, and then it has another parameter, and then it calls the operation provided as an argument and provides the parameter as an argument for that one. So if that sounded confusing, that's because it sort of is. But anyway, let's see how it works. So let's see, print perform operation len and A, B, C, D. So what will the program output? Yeah, it outputs 4. And why? What happens here is that the len is now the function. We don't call the len function. We provide the len function as a parameter for this one. So the operation will get value of len, and A, B, C, D is provided as a value for parameter. So basically, as you there's again was something wrong with the internet connection. Hopefully you didn't miss any of my talking, any of my wisdom. Anyway, what happens here effectively, as someone mentioned in the chat, is we call the len function with parameter ABCD. So what will this one output? Yeah, again, it outputs 1 because now it calls the perform operation function, calls the min function with this parameter list 1, 2, 3, 4, 5. We can also provide a lambda function in here if you want to. What? Mm-hmm. Okay, this one is definitely more complex. What do you think this one will output? Yeah, that's a correct answer straight away. But I want you all to think about this for like 30 seconds or something. What's happening in here? Now we are sort of combining a lot of things we've been talking during the last 2 weeks. There's a list comprehension and a lambda expression, and then we are providing a function as an argument. So it's sort of a complex thing. If you can read it, that's great. If it seems sort of complicated, that's fine. And this is actually a complicated. This whole operation is sort of overly complicated in a sense that you're not supposed to use these like this, but this is just to show you what's possible. So basically what we have here is we define a function with lambda expression, and the function has a single parameter x, and for x it performs this operation, this list comprehension, where we pick all the characters C in X if not all, sorry, all the items C in X if the item value is larger than 0, and then another parameter for this one. This one over here gets the value of this list in here. So basically, we get a list with all the positive numbers in this list. But the whole idea is just to sort of show you that we can provide a function as an argument as well. Why is this useful? Well, a lot of times you don't need to do this. And whenever you're doing this, you are sort of making your code a bit more complicated than it was before, because this whole concept usually makes the code a little less readable. It sort of has a habit of doing that. But it is useful in some occasions. And for example, what I remember doing myself I mean, I haven't, this isn't something you're going to need for all the programs you write. But what I remember doing myself, I had a long list of data, and I needed to pick out, sort of filter out some of the lines based on some different conditions, and I needed to create like several result files based on a single source file. And in each case, the filtering operation was different. So I wrote a single function that sort of function, like, I'm not going to show you the exact, but something like this, where I have a source file and a target file, and then I have an operation which is callable. And then inside this function, I read a source file, I perform this operation for each line, and if the outcome is true or whatever it was, then I write it to target file. And then I can call the same function with several different operations, which can be, some of them can be really simple, some of them can be quite complicated, but regardless, I can filter the same files with just calling the same. I don't need to copy and paste the function or do anything like that. I can just have the operation performed for actual filtering to be one of the parameters for the function. Yeah, here x is the list of numbers, but when lambda is used with sort, x is each element in the list, right? X is a parameter. Yeah, I understood. For the previous example, let's see if I can get it back. Yeah, for this one. So in lambda, x is a parameter, so it can be anything. The x is whatever you decide is, or whatever it is in that context. So for example, in sorting, but again, I think it's a good idea to use like meaningful variable names. So if we have a list of numbers or list of tuples, for example. Anything over there? Yeah. So if I'm using lambda, this is fine. But even this one, item is, well, item is probably a better variable name than, or better parameter name than x in this case, for example. If I change this to x, then it's less meaningful. And better to call it item, because that's what it is. That's what we're using the function for. The function receives all the items or all the elements, whatever you want to call them, as arguments, and then returns something based on that one. So again, we basically started this course by talking about the fact that you need to name your variables properly to make your code more readable, and that still applies for this final lecture. We still need to do that. And again, it's especially important with sort of expressions like this, which can be really difficult to read if you're using something like A and B and C for variable names. Okay, let's see. Is there something, again, these slides are directly from materials. Let's see, seeing that if I forgot to say something, use function as an argument. Okay, then let's talk about something else. Let's talk about something called generators a bit, which is again a really sort of a Python-like thing. And the idea of a generator is that it's sort of a comment that we need some values from a specific series. It could be something traditional like the Fibonacci numbers or strings generated in a certain way or whatever. But it's also sort of typical that we know we don't need them all at once. So we could generate all the Fibonacci, well, not all the Fibonacci numbers, but something like first 10,000 Fibonacci numbers. We know how to do that in a list. But if I only need like one Fibonacci number at the time, then it seems sort of overkill again, because we need to have space to store all those 10,000 elements and so on. And what we can do is write something called generator functions. And the idea of a generator function is that it returns one element at a time based on whatever code we write. So let's have a simple example. Something like call it value, and then we have maximum. Now this is something new. So basically this looks like a normal function, but the difference is that instead of return, we use another keyword called yield. And the idea of yield is that it returns the number, but we can get back to this function the next time. So it sort of remembers the state of the function. It's like it's sort of like a return, but there are differences in a sense that it doesn't. Although the execution is stopped for now, we can get back to this one. So what it means is that let's initialize a generator with maximum value of 10 provided as an argument. And then what we can do is we can ask values from that generator by using the next function like this. So it returns 1. And if we call it several times, it returns 1 value each time. So calling a value from a generator gives us the next value as long as there are numbers remaining on the generator. We can also iterate through any generator. Like this. So what do you think this one will output? There's a question, but I also first, please tell me what this one outputs. Yeah, it outputs numbers from 1 to 10. So basically, and if we change the generator creation 5, then it outputs numbers from 1 to 5. I'm going to answer the question in a second. I just want to show you something. What will the program output now? Again, you can just sort of say it in a short form. Don't. What do you think happens now? It's from 1 to 5, but yeah, it outputs 1 to 5, and again, and then nothing. And the basic idea for this one is that each generator after creation can only be iterated through once. So it's like the idea is that generator holds all those values, and when you get all those values out of the generator, then there's nothing left. And there's no way to reset a generator or anything like that. What you can do is create a new generator. So I can do this one again, and then it works. Then it gives me another 5 numbers. But the basic idea of generators is that they only hold those values once. Good question was that what happens when we call a next item? So does it execute the entire block, or does the yield return the number immediately? Yielded probably, or yielding. I don't know if those are actually proper words, but it doesn't really matter in this case. They are now. So let's see if we call the next for generator, what happens. We get the yielding value and then 1. So it seems that it is, come on. So it seems that it displays this message in here. And then when we call yield, then the execution stops. But then when we call the yield again, then it executes the rest of the block. So basically the execution stops in here, and then when you call the generator again, then it executes the remaining block, and then it continues execution from the beginning of the block. So that was an excellent question. So it's sort of similar to return, except that yield is like a return, but it remembers where it stopped. And when you call the generator again, then it continues on where we stopped the last time. So it's basically like a return, but yeah, the generator also holds a reference here, basically because it knows where it was. The generator remembers its state is probably like the proper way to put it. It remembers the state where it was when it yielded a number, and then when you want another value from a generator, then you continue from there. Again, there can be several yield statements in different if-else blocks and things like that. The thing to understand about generators is that if we keep calling the next, like this, after the generator is done, you can no more, let's get rid of those, and you can no more get values from the generator. What happens is that it raises a stop iteration event, or yeah, it's not an error as is, but it also sort of seems to behave like an error. So this is similar to what we talked about, was it last time or like 2 weeks ago, when we talked about iterating through our own objects, or through objects created in our own classes. And we found out that the stop iteration is what we need to raise to tell the for loop that there are no more numbers to fetch. So what we can do in some occasions is something like try, let's have a look. And then we can accept that there's going to be a stop iteration. Something like this, for example. So we get all the values from the generator, and but usually if you want all the values, then for loop is definitely what you want to do. But something like this is also useful in some occasions, because we may want to get some values and then do something else, and then try to get some more values and again do something else, and so on. Generators are really useful. Again, you can do without, but I sort of recommend that you practice doing this a little bit, because there are some occasions where this can really make your life a lot easier. Another way to generate a generator, yeah, in Python is to use syntax similar to list comprehension, but except instead of square brackets, we just use like this parentheses. So we can state something like x for x in range from 1 to 10 or something like that. And then, well, we can actually use the same for this one, and then it just provides us, it recreates a generator with values from 1 to 9. If we want to have squares of all these values, we can do something like this. So we get squares of numbers 1 to 9 like this. So again, if your generator, if the value can be expressed with a single expression, again, like in this case, you can just use this syntax similar to list comprehension. Like this, it also accepts the conditional part. So it's like exactly similar to list comprehension, but because it's a generator, sort of a generator comprehension, although I don't think that's the term actually used in Python, but sort of like a comprehension where values are created one at a time. So if you don't need all the values at once, but you just want to have all the values one at a time, then this one, something like this, can be useful. Is there anything you want to know about the generators? Anything more you want to know about the generators? The basic idea is, again, it's quite simple. Applying this might be a bit more complicated because it's sort of a feature that's also easy to forget. because a lot of these things you can do by using some other features, but it's useful to remember that whenever you're creating a sequence of something, you can think that whether you actually need all those values in a list or somewhere, or whether you just need some values one at a time. Okay, then we're going to talk about a couple of functional features, and let's talk about 3 specific functions. In this case, we talked about the functional paradigm a little bit at last time. The basic idea of a functional paradigm is that we try to avoid the changes in a state of program. So what basically we try to avoid of having variables holding the state of program. Instead, we are trying to have functions which are calling other functions and so on and so on. So lambdas and lambda expressions and list comprehensions and things like that are examples of this one, because we are creating something with a single expression instead of having, like, for example, like a loop where we have where we are having variables and things like that. There are other programming paradigms. The imperative or procedural paradigm is the basic thing we started this course with. So the imperative paradigm basically means that we have consecutive statements which are executed one at a time, and then we can have some control structures like loops and conditional statements to sort of control our program flow. And procedural basically means the same thing, except that we can divide our program into procedures. So in Python we talk about functions, so we can have like independent functions which we can call from the main program or from other functions. And the object-oriented is the one we talked at the beginning of this advanced course, where we write classes and create objects out of classes. The thing about Python is that it sort of supports all the 3 major paradigms, like the procedural and functional and object-oriented. You can use all of these in Python. And for example, if you use a language like Java, for example, then Java is it has an emphasis on object-oriented programming. In Java, all the code needs to be inside classes and so on. That's a good question. Is the reason one would want to avoid changes in a state like a technical point of view? No, it's not really not more memory efficient or anything. It can be depending. It can be more efficient or less efficient depending on what you're doing. It's more about the view of the programmer, so easier to write code, easier to maintain code and things like that. And it's just a different paradigm. And the thing is that a lot of problems you're trying to solve with programming can be solved with any of these paradigms. You can write programs which follow different paradigms and still solve the same program. And some of them are easier to read, but it's also about what you're accustomed to and what you're used to using. So probably the best paradigm to use might be the one you know the best. But some programs are more convenient to write in some paradigms. And in my opinion, and I'm no way saying this is the only correct one, but what I like to do is that I like to sort of the procedural with some hints of functional paradigm when I'm writing something simple like scripts where I'm dealing with files or whatever. And if I'm writing something more complicated like longer programs, then I tend to, at least to some extent, to use the object-oriented paradigm, because I think the whole idea of writing your own classes and objects like that is it gets useful when your program gets more complicated. And that's hopefully how you see it as well. So when you have more lines of code and more different parts in your program interacting with other parts, then the classes are definitely useful. But if you're writing something short, then the whole procedural thing is probably enough. But the whole concept of programming paradigms and things like that, it's a whole like area of computer science, and people are researching and have been researching that, and there are probably numerous theses and things like that written about that one. So in this point, I just want you to know that there are different kind of paradigms and what we basically mean by them. But let's talk about 3 sort of functional functions in Python. And the first one is called map. And the idea of map is that we provide a function and then a list or like a sequence, and then that operation is performed for all items in that sequence. So we could have a list of numbers. Like this, and we could say that let's have a lambda keyword, lambda expression, lambda function. Something like this. What we have here is that what the map does is it picks all, or you have a sequence of numbers, and then it performs this operation for all those numbers. So it basically increases all the numbers by 1. What do you think this one is similar to? How would you have done this if you don't? If you don't, yeah, list comprehension. This is what I'm trying to ask. Glad that you're quicker. So this is really similar to list comprehension, and some people prefer the map, some people prefer the list comprehension, or even generators, depending on what you're trying to do. I personally like to use list comprehension, so I rarely use map, but it can be sort of for some people. I think the map might be more readable or things like that. The thing to understand about map is that it doesn't return a list. It returns a map object, which can be iterated, or you can create a list out of it by, so difficult to write for some reason, list out of it by using a list function like we've been using before. Something like this if you need to have a list. But using list comprehension for this one is really easy. Filter is sort of similar. So for filter, we provide a function, and in this case, it needs to be a function which returns true or false. So again, you probably recognize that there's a resemblance to the list comprehension. We can use the list comprehension and then have the conditional part at the end, something like if number is something. So it performs the same sort of exact operation. In this case, we have an operation, and then we have a sequence, and it performs this operation for each item, and only if the value is true, then it returns. And it's included over there, and this one we also returns a filter object. So again, it can be iterated through, or you can convert it into a list, but it isn't a list as is. So filter and map are sort of really similar to list comprehension. The outcome, the resulting object is a little bit different, but the basic idea is the same. But the final one of this third, which we're talking about today, the reduce is a bit different. Let's see how. And in Python 3, the reduce was for some reason moved to a library called a module called functools. Functools, yeah, probably. Which is sort of difficult because I find this one the most useful out of these three. I use this one is and this one is also more difficult to replace with list comprehension or anything like that. The idea of reduce is that let's again have the numbers list, is that the outcome of reduce is a single item, single value. It's not a list. And we provide a function or callable for this one. We can use lambda, but it needs to have 2 arguments, or 2 parameters, sorry. And what it does, it performs sort of this operation to combine all the items into a single item. So in this case, it provides us with the sum of all items. So this is sort of similar to using the sum, but we can do anything with these items. We can multiply them. So we basically have the product of each of these numbers in a list, which is great. This is something that you need to do in a loop in other occasions. And we can do whatever we want with these. Let's have something else. Let's have like names. Reduce and so we can, for example, concatenate a list of names into a single string like this. Do something like this if you want to. There's also an optional third parameter for reduce, which is like the starting value. Like this, for example. So then we have this, but then you need to remember that the and also comes into beginning. So in this case, it's not useful, but something like this can be sort of useful. Although you can do this exact thing with join as well, and but then it's typical to programming that whatever you're doing, you can probably do it with other way around as well. But you just need to decide which is the most convenient way to do it. All of this can be functional programming in a sense that we have a single function which performs an operation without needing to write a loop for that. So the functional part of this is actually the fact that we're doing something as an expression instead of having several statements performing that. So we don't need any like additional variables for this one. So in actual functional programming, you're basically calling functions which call other functions, and then you provide the return values of other functions to other functions. And they also have a syntax which supports that a little bit better than the Python's. But this program in itself, it's not really functional program in a strict sense, but some of the things we're using, like the reduce function, in this case, it's sort of functional programming. The internal structures can contain loops. Yeah, that's not provided here. So how Python actually executes this is but that's also something that's not really defined in Python's definition. There can be several implementations of Python, and they can perform this differently. It doesn't really matter. What matters is what operations you're using. And eventually, however you're programming, you are basically doing something with loops, because computer processors works in loops. They perform loops over there. So in practice, even if you're doing functional things, your computer processor is still doing some kind of loop. So, but the functionality sort of applies to structures you're using in the language itself. We're not really going to talk about paradigms in detail, as I mentioned before. If you're interested in functional programming, we have a Haskell MOOC, and Haskell is a functional programming language which you can take. It's also really available in MOOC.fi. It's a really fun course. It's a really sort of different language than the Python, for example. So it might be, at least you can take a look, even if you don't want to learn the language, but to see how it sort of behaves differently in some occasions. Okay, the final thing we're going to talk about today and this course, and in these lectures at least, is something entirely different. It's not about functional programming. It's about strings or text, and it's called regular expressions. And what we mean by regular expressions, it's sort of a language on its own. It's not a Python thing. Sorry. Almost all of the modern programming languages support regular expressions. And what they are used is to, is to filter and search for strings inside other strings. And they have their own syntax for defining the set of accepted strings. And we are going to take a look at some of the examples here. The thing about regular expressions is that the language can be sort of complicated. It's not meant to be really readable in a sense that it's just like a bunch of control characters, one after another. But another thing is that it can be really effective. You can really create really impressive outcomes with a single regular expression. And it's typically used for things like validating strings. If you have a string that needs to have a certain format, like an email address, it's sort of easy to write the regular expression that checks that your email address has everything that needed. Like there needs to be something before the @ sign and then something else after the @ sign, and all the parts need to have at least a certain amount of characters, and then needs to be a dot, and only certain domain suffixes are accepted and things like that. But anyway, let's look at some of the basics. I've wrote this as because we're concentrating on the syntax of regular expression. I have this sort of a program body in here. What it does is we import the RE package or RE module, which is for the regexes, certain for regular expressions, RE as it states in there. And then this compile is used to create a new regular expression pattern, which we can use to match again which we can use to match certain words against, to find out if they are accepted by the rule we just defined. And regular expression looks something like this. So let's say that we write the regular expression pattern like this: hi, hello, or hi, HEY. And what this means is that now this accepts any pattern which contains one of these strings inside it. So this, what do you call it? Vertical bar, I think there might be another term for this one, means that these are all, it's like OR, these are all acceptable parts. So if you do this one, so if I give a word, if it's any of these words, this is accepted, or hello is accepted, or hi is accepted, and anything that contains this is also accepted. So this one is fine, and this one is fine, and this one is fine because they each contain that part. But if I write something else, then that one is not accepted. So it needs this means that one of these parts must be included in there. So one of the rules is that we can have several different alternatives by using this vertical bar. Yeah, I think it lagged for anyone. It just displayed a message that there was something wrong with the internet connection. Anyway, so what I was saying, that the vertical bar is, yeah, that one works as well. My name, hello, and then a bunch of gibberish. It's fine because the hello is found inside there. It doesn't need to be a complete word because we didn't define it like that. It's just that this string must be found. One of these strings must be found inside the string. There are other rules and there are various rules, and we're not going to talk about all of these. I can show you some examples. We can have a group of accepted characters written inside square brackets. So we can have something like this. A, B, C, D, E, for example. So now this accepts any string which contains one of those characters. So if I have or hello or these are all found fine. If I have something like RTU, which doesn't contain any of these characters, then it's not okay. I can also list a bunch of characters by using a hyphen. So A dash E means that all the characters from A to E. So again, this accepts all A, B, C, D, or it can be in middle somewhere. But if it doesn't contain any of these characters, then it's not found. So this is useful in a sense. Even E. The compile actually sort of creates this rule, and so it doesn't actually compile anything. It basically just creates a rule based on this regular expression we give out there. So this variable could be like a rule or something. It's not a string, but it's like a regular expression pattern after this one. Or yeah. It compiles a regular expression pattern, returning a pattern object. So then this pattern object can be used to find out if a certain string satisfies the condition defined in here. There are, as I said, there are a bunch of rules, and this even included in the material. So there's really no point. If there are some things we could see as a combination. If I have this hat character, it means that something needs to be in the beginning of a word. So let's do something like this. And now the rule states that, oh, it's running. Let's stop it and then let's run it again. What did I do? I did something I was not supposed to do. Oh, I closed it, sorry. Yeah. So now if I write something like this, no, that one, then it doesn't work, but example works because it starts with one of these characters. So this hat means it needs to start with one of these, and then we can combine this with other rules. Zero or more characters in the beginning, and then let's say that it needs to end with O. So again, this dollar sign at the end means that it needs to end with whatever was the final part of the pattern before that. So if I execute this one, now something like auto is there's something wrong with that one. It begins with A. I need to do this one. And well, hopefully at this point you understand that this is, as I said, this can be really not readable, this code. What am I doing wrong? I have no idea. Oh yeah, sorry. This one now states that there needs to be, I need to state whatever characters there is. So now this asterisk also means that this needs to start with A or E, and then it needs to include 0 or more of these A's and E's in it. So and so on. But as I said, there's really no point in me showing you all of this, because this is something you definitely need to practice yourself. And this is also something that's sort of easy to forget, but really easy to remember again. I haven't used this myself in a while. I'm sort of rusty with this one, but anyway, the basic idea is that if you don't use this all the time, then you probably forget at least some of these rules, and that doesn't really matter. There are a lot of places in the internet where you can find existing regular expressions. So if you're validating an email address, for example, just Google for email regex or something like that, and then you probably find a bunch of existing regular expressions which you can, or existing patterns which you can use yourself in your own programs. There are also some great sites where you can sort of create your own rules by picking something from a menu. Something like this needs to be included and things like that, and then it provides you with the pattern, and also some web services where you can provide a pattern, and then it explains it to you in English, like what does it mean, things like that. But yeah, I think this is something that doesn't really need any more examples. This is just something you need to perform yourself. We have some simple exercises where you need to validate something. I think there was a dates, a string containing a date, for example, or a weekdays or things like that. Yeah. So anyway, this was the final lecture. The 2 remaining weeks in this course are dedicated to game programming, and the idea really isn't to sort of to teach you game programming. It's something you're definitely going to learn some game programming, but the idea is to show you how to write a bit larger project with Python. So how you can combine everything you learned so far into a single program, like, well, you've been doing that before, but and also show you how you can use an external library, in this case something called a Pygame in Python. So what it means is that you install an external library and how do you use it, and so on. So then the same applies for other libraries as well. So whatever you want to do with Python in future, whether it could be like data analysis or game programming, or it can be something to do with machine learning or artificial intelligence or things we've been talking about in this course. There are probably libraries that will make your life a little bit easier. Do you have any final questions at this point about Python or programming or about this course? Or you have a project to make a small Pygame. It isn't graded in a sense, it's peer reviewed, which means that you all write a game and then you all peer review a couple of other games. So you take a look at what other students have written and then you grade them. The there's exam date in the course material for advanced course. There should be at least. I don't think we have any courses on graphics programming as is, but again, it's not that difficult if you just take a look at the libraries. When you know how to just use the basic Python features, you can probably learn to use the libraries yourself. And then there are some freely available MOOCs on graphics programming in Coursera and places like this. I don't think I'm not 100% sure, but I haven't heard any about any graphics programming courses like that. The next courses you can find in your study guides, or you can take a look at what we have in MOOC.fi to see what courses are available over there. Also ask your study counselors or the people who are giving you study guidance to check for any other courses. You can also email me if you want to know about anything particular. Okay, anyway, it's been great 12 weeks. Thanks for listening. The due date of last week exercise homework is again similar. So no, it's not. We promised that you can perform the final project a little bit longer. We decided it's at the end of December, I think. This was something we agreed on. We are going to update that date in the course material. The final exam won't be graded probably during this year because there's a lot of things happening at the end of the year, and I think you all agree with me that everyone could probably use a couple of days of vacation time as well at the end of the year. So you need to have rounds or parts 1 to 12 completed when you start the final exam, but you can complete the final project after that one, as long as it's done by the end of the year. Yeah, I think we can agree on that one, because I know that you have a lot of things happening. A lot of you have a lot of exams happening, and but parts 1 to 12 need to be completed before the exam. So this is similar to what all the other exams were about. There are exercises in part 13 and 14. In part 13, they are about using the Pygame, and most of the exercises don't really have tests in a way that you're supposed to find out if it works by yourself, because a lot of the exercises are things like have this thing move around on your screen. So they are really difficult to test, but they are more about performing the things. And then part 14 is about writing your own game, and then peer reviewing other games. Parts 13 and 14 are calculated on your final score. Yes, they are. So there are exercises which you need to complete, and you get points, but there are less exercises. And in part 14, there's basically like one exercise where you return your final project, and then there's another exercise where you do the peer reviewing other projects. It's a difficult word. Regex is, yeah, regular expressions are part of this course, so it's possible that there might be some in the exam. But again, regular expressions are, again, most of the things you're doing with regular expressions you can do without. You can perform the same string operations with other tricks, but regular expressions, if you know how to use them, are useful and can make your life a lot easier. So in the final exam, there won't be a question like use this specific programming technique to accomplish this. But there are questions like the ones you've been having during the course, that this is the problem, solve it, and then you can use whatever techniques you want to solve it. There can be things like write a class that does something and things like that. But there probably won't be a question which states that you need to use the regular expression to accomplish something. Anything else? Yeah, needing to complete parts 1 to 12 before exam means doing 25% from each part, right? Yeah, 25% was the minimum needed from each part, but then just remember that your score also affects your final grade. So half of your grade comes from how many points you have completed in the material. But 25 was the minimum, yeah. 25% per part.